Welcome to Structural Engineering Online. In this lecture, we will learn how to calculate the tributary load from one-way and two-way slabs. Please subscribe to our channel if you have not yet subscribed. In this video lecture, we will learn how to calculate the tributary load from one-way slab and two-way slab to the supporting beams. First of all, we should understand what is one-way slab and what is two-way slab. According to ACI 318, it says that if long side to the short side ratio is less than or equal to 2, then it is known as two-way slab. And if L by B ratio is greater than 2, then it is known as one-way. So this is the definition of ACI 318, which is American Concrete Institute. And based on this, we will be considering our slab as one-way or two-way. Now, what is one-way? One-way means the load will be transferring only on the beams in one side. That means only on two beams the load will go. And in the case of one-way slab, the load goes only on the long sides. That means the bending is only about one axis. But in the case of two-way slab, the bending takes place about both the axes, so it is biaxial bending of the slab. So now we take one example, and with the help of that example, we will learn how to calculate the load from one-way slab and two-way slab to the supporting beams. And for that, we have taken one slab which is here. First, I will take a one-way slab, so it will be easy for you to understand. So here is a slab which is (2-meter) width and 5-meter length. This is 2 and this is 5. And the load on this floor slab is 2 kilonewton. So floor load is 2 kilonewton per meter square. So whenever a slab is given, we will calculate whether it is one-way slab or two-way slab. Just look at the long side and the short side and take the ratio. So here in this question, the long side is 5 and the short side is 2. So L by B, which is 5 divided by 2, it is equal to 2.5, and this is greater than 2. That means it is one-way. Now for one-way slab, it is very simple that you can just divide it in this way. Take the half of the short side and divide this whole rectangle into two parts. Like this, you will get two rectangles. And the load which is coming to these long beams, suppose this is A, B, C, D. So in this case, AB and CD are the long beams and AD and BC are the short beams. So as I mentioned that the load will come only to the long beams and the short beams will not take any load. Now how much load will come to AB? That we can calculate according to this. So load on AB is equal to the area connected with AB multiplied by the rate of loading. So here we have the area, which is rectangle, area which is connected with AB. It is rectangle, and for that we have 1 meter is the width. So 1 into 5 is the area, and the rate of loading which is on this floor area or slab area is 2 kilonewton per meter square. So we multiplied by 2 kilonewton per meter square, and with this we get this value as total load on the slab will be just equal to 10 kilonewton. Means the load on this beam AB is equal to 10 kilonewton, and similarly the load on CD will also be 10 kilonewton, which is because it is connected with the same type of area. Now whether this load will be uniformly distributed, it is very clear that the load will be uniformly distributed. If you see that it will be uniformly spread on this beam. So what will be the intensity of this UDL? So UDL we can calculate as total load divided by the length. Total load is 10 and the length is 5. So this is equal to 2 kilonewton per meter. So this is very simple to calculate the load transferring to the supporting beams in case of one-way slab. Now we take one example for a two-way slab, and in case of two-way slab, now I'm taking this slab which is having these dimensions here. Here is 3 meter, this is 2 meter. Okay, now in this case, as we see that the ratio L by B ratio is 3/2, this is 1.5. So we can decide that this ratio is less than 2, therefore 2-way. So in the case of two-way slab, how we distribute the load? The load will go to all the 4 beams. If you say that this is A, this is B, this is C, and this is D. The method of dividing this whole area is like this. You divide these angles into by just 45, 45, and like this. So 90-degree angle is divided into 2 equal parts of 45, 45. Now we get 2 triangles and 2 trapezium. So here we have a triangle, this is triangle, and this is trapezium here, this is trapezium here. So the simple rule is that the area which is connected to the beam will transfer the load to that beam. So we can say that from this triangle the load will come to AD, and here the load will come to BC, and from the trapezium the load will come to AB, and from this trapezium the load will go to CD. So same logic will be used. We will calculate the area of the trapezium and triangle and then multiply that area with the rate of loading which is given on the slab, and in this case also we have taken that the rate of loading is 2 kilonewton per meter square on the slab. So first we calculate the area of trapezium and the area of triangle. So we can say that the load coming to the beams is just depending on the area which is connected. Now to find the area of trapezium or triangle, we should know what is the height of that triangle or the trapezium. So if we look here, we can easily calculate that because these angles are 45 degree, so both the angles are 45, 45. So in that case, we can say that this two sides, if I say that this is E and this is F, right? So in that case, this will be just half of the base, half of the base here, and similarly these distances will be 1, 1, and this distance will remain as 1. Just in this, if you look at this triangle, I will show here. This is B, this is C, and this is E. If we draw a perpendicular here, that perpendicular will definitely divide into two equal parts. Okay, because this is 45 degree, this is also 45 degree. So half half, and the similar way, because this angle is also 45, so we will get on the other side also equal to 1, 1. So first we will find the height of the triangle, and that you can easily calculate from this distribution, right? So now we go to calculate the load on AB, which will be equal to area of trapezium ABEF multiplied by the rate of load. Now the trapezium area we can calculate. We already know the formula of the trapezium area. It is h by 2 into sum of the parallel sides, right? Trapezium area. So in this case, now we have h, the height of the trapezium, which is just equal to 1. So 1 by 2. Then parallel sides EF and AB. EF is 1 and AB is 3. So we get this area as 4 divided by 2, that is 2 meter square. Therefore the load on beam AB is equal to area, which is 2, multiplied by the rate of the loading. Rate of loading is 2 kilonewton per meter square, and area is meter square. So what we get 2 into 2, 4 kilonewton. So total load on this beam AB is equal to 4 kilonewton, and similarly the load on CD will also be same. Load on CD also equal to, that is same, 4 kilonewton. This is the load given in terms of kilonewton. Now if somebody want to calculate the intensity of this load, this is your trapezium. So this is W per meter, and this is your length, which is 3, and this one is 1. So we can calculate this W. Similarly, this is the load diagram. So the load diagram, if you take the area of the load diagram, that will be equal to the total load. So load diagram, we can say W by 2 into 1 plus 3. This is your load diagram, and from the load diagram, when we take the area, that is equal to the total load, which is 4 kilonewton. So from here we can say that W is equal to 2 kilonewton per meter. This is the rate of loading on trapezium. Now we calculate the load on the smaller beams, that means BC and AD. So in that case we have this triangle. So now we come to the load on smaller beams. Which are BC and AD, right? So when we look at BC, we have the triangle, and for the triangle which is BEC, so load on BC is equal to the area of triangle, which triangle? BEC, area of triangle BEC multiplied by the rate of load. Okay, now the triangle BEC, if you see, half base into height is the formula. Base of the triangle is 2 and the height is 1, so we can calculate the area. Half into 2 into 1, this is area of triangle, and the rate of loading is 2 kilonewton per meter square. So we get this value as how much? This is equal to 2 kilonewton. So in this case, the load on this beam BC is equal to 2 kilonewton, and similarly the load on the other smaller beam, which is AD, it will also have the same 2 kilonewton. Now if you want to calculate the intensity of loading on this beam, as we have done in that case, suppose this is W per meter, here you have 2 meter, right? So we will write the same thing, the area of the load diagram equal to the total load. The area of this load diagram is equal to W by 2 into, so half base into height, so base is 2. That will be equal to the total load, and that total load is equal to 2. Therefore W is equal to 2 kilonewton per meter, the rate of loading on the beams which are connected with the triangular load. That means the shorter beams will also have the intensity of loading, which is maximum intensity of the triangle, as 2 kilonewton per meter. So with this, you have seen that very easily we can calculate the load transferred to the beams which are supporting the slab, which is either in the form of a two-way slab or one-way slab. We can easily calculate the load to the beams. I hope with this explanation you understand how to calculate the load coming to the beams. So please you share it with your friends, and also click on the button of like and subscribe to our channel. The subscription is free of cost, so that in future when we upload any new video lecture, you will get the notification. Thank you very much.